So, many students having a query about the materials of the digital fundamental due to the midterm exam. So let me show you. If you open your canvas, the dashboard will open. But into the dashboard, suppose you have a different subjects offered by the faculties in a canvas. So you see a dashboard like this. So we have three subjects, but generally you have to go to the subject of a digital fundamental. This this is the home of the digital fundamental. We'll change the date for submitting the experiment number 1 and 2. So you have to remember that the date of submission, submit the experiment number 3 and 4 is 28 September. Okay, so before 28 September, all of you, before 28 September, all of you have to submit the experiment number 3 and experiment number 4 in Canvas. Okay, it's your duty to submit the experiment on time. I will not change the date every time if you miss to submit the experiment. Okay, because I have to also ask to the other faculties because uh, we are four faculties taking the subject in different classes. So I also have to take the permission of the subject coordinator and then I have to change the date. Okay, so now it's your duty to submit the experiment number 3 and experiment number 4 on time. Uh, that's only I said. Wait for that. Now you have to prepare a Word file by yourself. Okay, just you have a Word file of action number 1 and 2. From that, just you have to change here action number 3 by using a link of action number 3 and 4 in virtual lab. What you have to do, you have to write the aim of here for action number 3. You have to give the link of the action number 3. Apparatus remain as it is. Then we have to draw the here the diagram. No need to write the pin diagram of IC. Our action number 3 is the half header and full header. So what you have to do, just you have to write the a diagram of a half header, a diagram of a full header, then the procedure. Okay, and for the question answer, just you take the question answer of pre-test and post-test. So this is the thing only you have to make by yourself. Okay. So experiment number 3 and experiment number 4, you have to do by yourself. Anyone having any doubt in this? Okay, reminder I will give you on your WhatsApp. But how to make a Word file? Just make a Word file by yourself. It's not a big deal. Just you have to write here experiment number 3. Then it's okay, Sanjana. If you do not write the MCQ or quiz, it's not compulsory. Okay, it's not compulsory, but those who have a pending and have to, sorry, those who have a pending to submit the assignment, sorry, experiment, they have to write the experiment number 3 and 4 by themselves and submit it. Okay. Now again, come to the canvas. So from where you get the material, and also you have to submit the assignment number 1 and assignment number 2 before October 5. Okay, before October 5. So assignment number 1 and assignment number 2 both are available in the canvas only. Just you click on assignment number 1 and then click on that link, this PDF. So you can get the PDF of assignment 1. Same way you can get the PDF of assignment 2. Now suppose you require the materials. So where you have to go? You go on the files. Okay. Once you open the digital fundamental, the home screen will open. So this is our home screen. Okay. Then go to the files section here. Click on that. You see here all the things are available. Okay. So just you have to go to the files. So if you require the material or a soft copy of books, there is one folder of books. Click on that. So the books, so most of the books is here. The two books which I referred is the Morris Meno, which is the Digital Logic and Design. You can say the DLD, and the Digital Circuit by Anand Kumar. And the Digital Circuit by Anand Kumar. So you can refer these two books. If you want to download the book, just go to the, you can click here also, and then you can click here, there is an option of download, or you go here, there is a option to download the book. Okay, so the books is also available here. Again, go to the files. So most of you students are asking about the PPT. So the unit number 1 PPT is converted into a PDF. So if you click here, or just you can download it. Okay, it will take some time. So instead of this, you can click here and download. It's only a 1.6 MB file. So this is that PPT, okay, which we are using. So I request all of you to download the PPT from here. Okay. So all things are available in a file section. So you can check the file section in your canvas. Now, anyone having any doubt on that? Anyone having any doubt from where you can get the material? Otherwise, we will move forward. If it's clear, please write down clear. Okay, topics in syllabus of mid. You see the PPT. Okay, so that's why there are lots of topic remaining. Midterm paper is already designed. You start preparing yourself.
સર
Yes. Yes.
એટલે જે મિડ નો સિલેબસ છે ને જે મેલ આવ્યો તો અમારે
હા.
એમાં આ ડી મોર્ગન્સ
અવાજ કટ
અને
થાય છે.
બુલિયન ફ્લો એ બધું છે પણ એ આપણે બાકી છે એટલે એમ
હા, આપણે બાકી છે, મને
હાલો
ખ્યાલ છે. આપણે
સંભળાય છે
મિડસેમ ક્યારે છે?
પરમ દિવસે શનિવારે
આ સેટરડે છે આપણી ડિજિટલની.
હા સર સેટરડે ના છે અને આજે એક જ તમારો લેક્ચર છે તો પછી બધું કેવી રીતે કવર અપ થશે?
ઓકે, જોઈએ તો આજે હું એક એક્સ્ટ્રા લેક્ચર લઈ લઉં. મારી પેલા જેનો લેક્ચર હશે ને, અધરવાઇઝ કાલે લેક્ચર
હા
લઈ
સર
લઉં. આજે 12 થી 1 કોનો લેક્ચર છે?
સર
ડીએસ નો
તેજસ
છે
સરનો.
તેજસ sir નો.
તો હું એને પૂછી જાઉં. See, this section number 4 is already completed, which is logic gate. Okay, in lab only. So in section 4, it's very easy. They are giving only gates and truth table. I think all of you are aware about the truth tables. Okay, and also we studied about the NAND gate and NOR gate as a universal gate. This section number 5, logic families, this is not in our syllabus. Okay, so the logic families are section number 5 that we do not have to consider. Section 4 is already covered, thus the pending portion is section number 3, which is a Boolean algebra. Okay, today I think the codes are maybe completed. See, up to BCD subtraction we already covered. From today we have to start XS3 code. Again, and the binary to gray and gray to binary, today is our experiment is for that only, binary to gray, gray to binary. So I will take a extra lecture. Okay. So today or tomorrow, which day you are comfortable? Okay, so tomorrow I will take a lecture. Let me see the timetable. But tomorrow you have a lab sessions only. Yes, Parthiv. Okay, the accuracy is pending in section 2. So what we are doing tomorrow in the last lab session, the if there is a lab session of Rachit sir and Chetan sir with me. Okay, so lab session is I will cancel out for tomorrow, and last two instead of lab I will take a lecture. Okay, last two session of tomorrow. It's okay. I will talk to the Rachit sir and Chetan sir, and instead of lab we will take a lecture. And if the time is pending, so, we will do the repetition also. Okay. Okay. So tomorrow we will take a lecture of that. Okay. Yes, these are section 1, 2, 3, and 4. All the four sections are in mid sem. Okay. But in mid sem there is only a MCQ. So no lengthy question will ask. So you have to think about that. Which type of question will be asked in from you give the answer in 90 seconds or a maximum 120 seconds. So you have a, I think you have a 1.5 minute for one question. I don't know. Okay, you have 60 seconds only. So just you have to prepare a questions, and we also ask the question which you give the answer in 60 seconds. Okay. So there not be a lengthy multiplication or lengthy divisions in that. So just prepare questions which will be asked, uh, and you give the answer in 60 seconds. So let's start today's session. So we already covered four experiment, which is a verification and interpretation of truth tables of AND or not NAND nor exclusive or and exclusive NOR gates. Also, we are performing the half header, full header, semi half subtractor and full subtractor, and also we are perform the universal gate, which is a NAND gate and NOR gate, which is work as a universal gate. NAND gate and NOR gate work as a universal gate. So now today we have to perform the, actually our, this is our experiment number 5, but in virtual lab it is a experiment number 11. Verify a binary to gray and gray to binary conversion. So this is a code conversion. Okay. So as we have a BCD code, the same way we have a XS3 code and gray code. We have XS3 code and a gray code. So we have to convert a binary number into a gray code, and also we can convert gray into binary. So there is a conversion, binary to gray conversion, binary to gray conversion, and gray to binary conversion. Okay, so binary to gray code and gray code to binary code. Move to the theory. So what is the actually requirement of the gray code? So the binary numbers is the default way to store the numbers, but some of the application, instead of binary numbers we require the different codes. That's why this code is available, like a BCD code or a gray code or error detecting code or error correcting codes. So gray code is also useful for the, suppose gray code is used to find a position of a rotor. Okay, suppose in a machine or a motor, the rotor will be rotate. So for finding a position of that rotor, we can use a gray code. So you can see the gray code has a property that two successive numbers differ in only one bit. Now what that means, that we will see. Okay. So gray code has a property that two successive numbers differs in only one bit because of the property of the gray code. Also it is known as the cycling code. Also it is known as the cycling code. So where we are using the gray code, so gray code is used in K maps. So K map is part of unit number 2. Also the error correction, we can use the gray code for communication with a machine. You can say motor. So communication with a motor also we are using a gray code. So there are some of the application of the gray code. So suppose we have a closed loop control, we have to control the speed of the motor. So we can sense the speed by a controller. So that controller work on the gray code. And that signal we will have to give the computers, but computers works on the binary number system. Then what we have to do, we have to convert a gray code into a binary. And again there are some program available in our computer, or you can say Arduino, and by programming that, again the signal will be converted and give to the motor. But again in a motor there is a controller which work on the gray code. So again we have to convert a binary number into a gray code. So gray to binary and binary to gray conversion is required for that. So this is the binary to gray conversion. So for converting a binary to gray and gray to binary, we are using the exclusive OR gate. We are using a exclusive OR gate. So how we can convert a binary number into gray number? So the common thing, let me take the example. Okay. So suppose we have a binary number 1 1 0. So this is my binary number, okay, and we have to convert that binary number into gray number. So how we have to do? The MSB of the binary remains same. The MSB of the binary remains same. So this is my gray number. Okay. The MSB remains same. MSB means most significant bit, or you can see, or you can say the uh, leftmost bit that remains same. We have to add this number with this exclusive OR adding. So if you remember the truth table of the exclusive OR, if you remember the truth table of exclusive OR, what is the truth table of exclusive OR? For 0, 0, it is 0. For 0, 1, it is 1. For 1, 0, again it is 1. And for 1, 1, it is 0. For 1, 1, it is 0. So 1 plus 1, we do not have to consider a carry. So 1 plus 1 is 0. Again add the successive numbers. So 1 plus 0 is 1. Again add another number. 0 plus 1 is 1. So that's how we are converting a binary number into gray number. The first bit remains same, which is known as the MSB. So MSB remains same. Then we have to add the first number to the another number. Then again the second number to the third with a fourth. That's how we are finding a or converting a binary into gray. So again, there are some of the rules you can see here. The most significant bit, a most significant bit of the MSB of the gray code is always equal to the MSB of the given binary code. So the MSB is the same. Then other bits of the output gray code can be obtained by XORing binary code bit at that index and the previous index, at that index and the previous index. So that's how we are finding the binary to gray. So this is the binary number. B3 is our MSB. So B3 is equal to G3. This is the equation of the binary to gray conversion. B3 is equal to G3. Then B2 XORing with a B2 is XORing with a B3. Same way now B1 is XORing with a B2 and B0 is XORing with a B1. So B2 XORing with a B3, it's G2. B1 XORing with a B2, it's G1. And B0 XORing with a B1, it's G0. Okay. You see, this is the circuit of the binary to gray conversion. This is the circuit of the binary to gray conversion. You check the circuit. So we are using the XOR gate for a conversion of binary number into a gray number. Okay. Now, what is the change of a binary to gray conversion? What is the actually gray code? So, what that says, see, what it writes, the gray code has a property that two successive numbers differ in only one bit. Differs in only one bit. Okay. So, what that mean? Now, you check the table. So, binary we have 0, 0, 0, 0. So, B3 is equal to G3. Then B3 plus B2, so 0 plus 0, again it is 0. B2 plus B1, 0 plus 0 again 0, 0 plus 0 again 0. So for 0, 0, 0, 0, of a binary number, the gray code is also 0, 0, 0, 0. Okay. Same way for 0, 0, 0, 0, 1, the gray is also same 0, 0, 0, 0, 1. But now the second one is 0, 0, 1, 0. Second one is 0, 0, 1, 0. You see here. So 0 remains same. So 0 plus 0, 0. 0 plus 1, 0 as it is, then 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1. So for 0, 0, 1, 0, for 0, 0, 1, 0, the gray code is 0, 0, 1, 1. The gray code is 0, 0, 1, 1. Now you check here, number 2 and number 3 cannot be highlighted. Let me copy pasted. Okay. Now wait a minute. It's not copy pasted, otherwise I will show you. Now what I want to say, here B3 is 0, 0, so B3 is not changed. You can see B2 is also 0, 0, so B2 is not changed. B1 is converted from 0 to 1. You check the arrow. B1 is converted from 0 to 1 here, and B0 is converted 1 to 0. So there are change in 2 bit. There are change in 2 bit, but in a gray code, you see here the G3 is same, G2 also same. Now there is a change in G1 only, so 0 to 1, G0 is remain same. So there is only a change of successive, only a change of 1 bit. So this is the actually application of a gray. This is the actually application of a gray code. So gray code has the property that two successive numbers differ in only 1 bit. Differ in only 1 bit. So this is actually the application of gray code. Two numbers are changed only one, by successive numbers differs by only a 1 bit. Differs by only a 1 bit. So this is the binary to gray conversion. Same way we have to the another conversion known as a gray to binary. Another conversion known as a gray to binary. So how it will be? Suppose you have a gray number 1 0 0 1. Okay, this is our gray number, and you have to convert it into a binary. You have to convert it into a binary. So again, the rule is same. The MSB either for gray to binary or binary to gray, it remains same. Now instead of next number, we have to add answer of binary to the next bit. So 1 plus 0, it is 1. Again add with 0, it is 1. Again add with 1, it is 0. So that's how it will be converted. For binary to gray, we have to add number like this. And for gray to binary, the MSB remains same. So what we have to do, the rule is, suppose, let me write here. G3 is equal to B3. G3 is equal to B3. Then for B2, what we have to do? B3 XOR with G2 equals to B2. Then B2 XOR with a G1, that's our B1. And B1 XOR with a G0, that's our B0. So this is the rule, okay. And what is actually G3, G2, G1 and G0? So the first bit is our G3, the second bit is our G2, the third bit it's our G1, and the last bit is our G0. Same way, this is our B3, this is our B2, this is our B1, and this is our B0. So B4 binary actually and G4 gray. B4 binary and G4 gray. So that's how we are converting a gray code into a binary. So let us check the rule. You see the rules. Let me zoom it. The first rule is remain same for both. The MSB of the binary to gray or conversion of gray to binary is remain same for both the conversion. Okay. So the most significant bit MSB of the binary code is always equal to the MSB of the given binary number. The other bits of the output binary code can be obtained by checking a gray code bit at that index, gray code bit at that index. If the current gray code bit is 0, then copy previous binary code bit, else copy invert of previous binary code bit. So no need to remember that thing. So this is the rule. G3 is equal to B3. Then we have to add answer of B3 this. You see here G3 is equal to B3. Then B3 with a G2, B3 with a G2. Let me copy this image. Okay. So B3 is equal to G3. Then B3 with a G2, it's B2. Then B2 with a G1, it's B1. And then B1 with a G0, it's B0. So anyone having any doubt regarding this conversion binary to gray or gray to binary? The gray code is used for the some of the conversions or gray code is used on the shaft of the motor. If you want to measure the speed of the shaft of the motor, then we are using the gray code for measuring the speed of or and then we are connecting the sensors which works on the gray code, which works on the gray code. Or also you can see they are also giving the application of gray code where the actually gray code is used. So gray code is used in the K map. So again the K map, no, gray code is also used in the K map. Okay, K map, the full form of the K map is Kirchhoff map, and it's this is the part of unit 2. The K map is used to reduce the circuit. K map actually used to reduce the circuit. So suppose we have a lengthy circuit with a numbers of gate. So by using a KMF, we are reducing the circuit. So we are reducing the numbers of gate. Suppose for a same output, we can use a 10 gate also, and with the same output we can use a 3 gate also. By using 3 gate also we can implement the same output, and some of the person implement the same output with a 10 gates. So the K-map is used to reduce the circuit. So again, it's the part of unit 2. So we will not more focus on that. That communication already I said, the communication, it's not communication like a phone call. It's the communication between the two, you can say programming. Communication between a machine and a computer. The gray code is used to measure the speed of the shaft of a motor. Okay. So we have a sensor which work on a gray code, and that sensor gives the output to the computer, but the computer understand only the binary number system. Okay, then we have to convert a gray to binary, and there is a program in the binary. Then you have to reduce the speed or you have to increase the speed. Again, that program will work, and they give the feedback to the sensors. But again, sensors works on the gray code only. Then we require the conversion of binary to gray conversion. So this is the communication between a sensor and a computer system. Okay. So generally, we are using a sensor which works on the gray code, uh, because it's it's very useful to measure the speed of the motor. So the sensors are known as a Hall sensor. So Hall sensor is actually used to measure the speed of the motor. Suppose if you want to control the speed of the motor, then you require the sensor. So that sensor sense the speed, that gives the speed to the system, or you can say a computer, and again the computer controls the speed. So that's thing. The sensors work on the gray code. So that's how actually a communication done. So okay, Henil, now it's clear. Okay, so this is the table of the conversion of gray to binary. So again for 0000 and for 0001, gray to binary and binary to gray remains same. The change will be comes from the 0010. It will change from the 0010. So now go to the pre-test. Okay. So now all of you have to give the answer. Let me zoom it. The first question is a code converter is a logic circuit. A code converter is a logic circuit that blank inverts the given input, convert into decimal number, converts data of one type into another type, converts to octal. So which answer is right? A, B, C or D? Okay, Parthiv gives the answer. Teja gives the answer. So the code converter is a logic circuit that convert a data of one type into another type. The primary use of gray code is coded representation of the shaft's mechanical position, turning on or off a software switches to represent the correct ASCII code to indicate the angular position of a shaft on a rotating machine, to convert the angular position of a shaft on a rotating machine into a hexadecimal code. So what is the primary use of the gray code? Either it is A, B, C or D. So no answer from anyone. It is actually a coded representation of the shaft's mechanical position. Okay. The next one is 4-bit gray code can be converted into a 1-bit binary, 2-bit binary, 3-bit binary, or 4-bit binary. If we have a 4-bit gray code, and if we converted into a binary number, so how many bits we have in a binary? 1, 2, 3, or 4? Okay. Parthiv only gives the answer. When we have a 4-bit gray code, and if you want to convert into binary, we have 4-bit binary only. You see the table B3, B2. This one, if we have 4-bit binary number B0, B1, B2, B3, then we have 4-bit gray code number only G3, G2, G1, Z0. And if you have 4-bit gray code and you convert into a binary, then you have 4-bit binary numbers. The gray to binary conversion can be implemented with AND gate, exclusive OR, NAND gate, or NOR gate. Which gate we are using for the conversion? AND gate, exclusive OR, NAND, or NOR? A, B, C, or D? AND gate, exclusive OR, NAND gate, or NOR gate? Which gate you are using for a conversion, gray to binary, or you can say binary to gray? Okay, Dhairya, you give the answer. Dhairya Karya. Give me the answer. Which gate we are using for the conversion of gray to binary? AND gate, exclusive OR gate, NAND gate, or NOR gate? Which gate this is? It's not maybe. It's exclusive OR gate we are using for converting exclusive OR gate we are using for converting binary to gray or a gray to binary. Okay, the last one is a binary code that progresses such that only one bit changes between two successive code. Only one bit is changes between two successive code is 9's complement code, 8421 code, XS3 code, or gray code. Which code it is? Yes, Valsi, you have to give the answer. Yes, Palsi. I think yes, Palsi is not there. The answer is D. Now submit the quiz. All are correct. Now we do not have to focus on a procedure, just go to the simulation. So there is a binary to gray code converter and gray to binary code converter. Go to the simulator 1. So this is the circuit. So there is a battery. So we have to connect a battery. So double click on the battery. I share the link with all of you. So now you can perform the experiment by yourself. So click on the battery, it is written connected. Then we have to add the truth table. So suppose all are 0. See, this is the conversion of binary to gray. So B3, B2, B1 and B0 all are 0, 0. So G3, G2, G1 and G0 is also 0. Add to the table. In simulator, they are using a NAND gate path. You see here the aim is only that verify binary to gray and gray to binary code conversion by using NAND gates only. By using NAND gates only. Otherwise, you can use exclusive OR gate. Suppose if we have a in college, so we are using exclusive OR gate only. IC with a exclusive OR only. Why they are using NAND gate? Because the NAND gate and NOR gate are the universal gate. So you can implement any gate by using NAND gate and NOR gate. So in virtual lab, they are designed the virtual lab by using NAND gate only. Otherwise, we can use exclusive OR also. Okay, so no need to use the NAND gate, and okay, you can verify the truth table by using exclusive OR also, OR only. So now let's take the another 0001. So again, the output of G3, G2, G1 and G0, you can see the LED is green and this is the red. So add to the table. The second one is 0010. So B3 is 0, B2 is 0, B1 is 1. So 0010, then we have 0011. Add. Then 0011, then we have 0010. Add. Then we have 0100, then we have 0110. Add. Then we have 0101, then we have 0111. Add. So that's how you have to add the up to 1111. In an exam, I also request all of you, please write down the table of a 16, up to 16 of a 4-bit. Okay, so that will help you. So 0 means 0000, 1 means 0001, up to 15, 15 means 1111. So it will help you. So this is 0101, then we have 0110. So 0110 means 0101. Add, then we have 0111. Then add, then we have 1000 means 8. Add, then we have 1001. Then we have 1010. Then we have 1011. Add, then we have 1100. Add, then we have 1101. Add, then we have 1110. Add, and then we have last port. So this is the actually 16-bit table you can see here. So that's how a binary to gray and gray to binary conversion is possible. Okay, so now everyone, you do the experiment by yourself. Same way you have to convert a gray to binary conversion also. So just you have to verify the truth table. Okay. So in exam, what they are asking, suppose I have a number 1, 1, 0, 1, 0, 0, and 1. So suppose let's say it is a binary number. Okay, and we have to convert into a gray number. In exam, this type of question only asked in a 1 mark. So what we have to do, we have to convert this one binary into gray. So MSB remains same. Then we have to add the numbers. One plus 0, 0. One plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. And suppose we have a gray number. Let's say 1, 1, 0, 0, 1, 0, 1. So let's say this is our gray number. And we have to convert into a binary. So MSB remains same, 1. Now we have to do the cross addition. So 1 plus 1, you can say 0. 0 plus 0, 0. Again 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. And 1 plus 1 is 0. So that's how we can convert a gray to binary. So you see the two example, binary to gray and gray to binary. This is binary to gray and this is gray to binary. So if anyone having any doubt how the binary to gray or gray to binary will convert, it's clear for all. If it's clear, please write down it's clear. Okay. So move for the post test. Convert binary number into gray code. So we have a binary number 100 101. Now converting 100 into 101, what is the answer? Either it is 101101, either it is 000110, or it is 110111, or it is 111001. Okay, Parthiv gives the answer. What about others? Okay, Henry gives the answer. I think 100101. Let me. Okay, this also gives the answer. 100. I think this is the actual the question. 100101. So we have a binary number and we have to convert into a gray. So the MSB remains same. Then we have to add to the next bit. So 1 plus 0, it is 1, 0 plus 0, it's 0, 0 plus 1, 1, 1 plus 0, 1, 0 plus 1, 1. So answer is 110111. So the actual correct answer is C. Okay. The next one is, if a two system have a different codes, if a two system have a different codes, then circuit inserted between them is which circuit? A combinational circuit, a sequential circuit, combinational sequence circuit, or conversion circuit? Okay, Parthiv gives the answer. What about others? I think others are sitting ideally like a Dipen, Dirga. There is no answer from the Keyur, Kusal. Kusal, sorry, Kisan, Meet, Mihir, Mitul, Silpi Kumari, Suhasini Ba. There is no answer from anyone. The circuit is used or known as the conversion circuit. The reflected binary code is also known as the gray code is also known as the reflected binary code. Okay, BCD code is the not reflected binary code. BCD code is the binary coded decimal. We do not have any binary code, a code name a binary code. ASCII code is the different thing. So the reflected binary code is the gray code. So Disa gives the answer. Very good, Disa. So code is a symbolic representation of discrete information, continuous information, decimal information into binary, binary information into decimal. So what is actually code? What is actually code? So actually code is the symbolic representation of the discrete information. All the digital numbers are the discrete and all the analog numbers are the continuously changed. Okay. Give me the final answer. Convert the gray code into binary code. So we have a gray code 0101 and we have to convert into a binary. Then what is the answer? Okay, so Parthiv and Henil gives the answer. What about others? See, the two answer A and C is not right. How directly you aware about that A and C is wrong? Because either conversion of gray to binary or the conversion of binary to gray, the MSB remains same. The MSB remains same. In the given example, MSB is 0. So only there is an option of B and D. Only there is an option of B and D because B and D start with a 0, A and C start with a 1. So what that means, your MSB will different. So there is a no point of possibilities that A and C is correct. So either you have to select B or D. Okay. So only two, Parthiv and Henry gives the answer. Let me solve it for all of you. 0. What's the question? Let me check again. 0101. So this is the question. Okay, Nupur also gives the answer. MSB remains same, so 0, 0. And cross addition. 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0. So answer is 0, 1, 1, 0, which is a B. To submit the quiz, 4, 5 out of 5 is correct. And there are some references. In references again, there are some links and books. Okay, so you can use that link or book for more about the binary to gray and gray to binary conversion. So now, anyone having any doubt in this binary to gray and gray to binary conversion? Okay. So today we have a lecture. Yes, any? You have any doubt? So your audio is okay. So today we have a lecture, and I will take two lectures tomorrow. Last two lecture, so we can cover our syllabus of a mid one. So you start preparing the topics which we already covered. So just you have to remember the things which we studied today and tomorrow. See, in a code BCD or a gray code, it's difficult to solve the example within a 1 minute. Okay, which example? BCD addition and BCD subtraction. Also, the we have a XS3 addition and XS3 subtraction. So if we have to give the example or ask the example, it will ask a very small example like 5 plus 7 or 12 plus 8, like 20. Okay. So focus on the questions or topic which will ask in single marks, and you have to write the answer in 60 seconds. Okay. So do the smart work for that. So thank you everyone. Now write down your enrollment number for the attendance, and then we. No, Parthiv. It's no need to prepare any another thing except that PPT. So thank you everyone for attending the session. So those who are already written their enrollment number, if they want to leave, they can leave the session. Okay, and I will wish you a best luck tomorrow because you have an exam day after tomorrow. Yes, Miloni. Okay, so Niyati and Jai, you write your enrollment number.